Okay, let's take a look at the quiz 10.1 to 10.3 review worksheet. See if we can come up with some strategies for solving these problems for the quiz. When you look at this quiz and you read the question, identify the name of the figure, the formula that you'll use, and the information that you need. So when I look at problem number 1 and I read that question, it says find the area of the parallelogram. So I want to write down the formula. The area is equal to the base times the height. Then I look at the problem and identify those pieces in the problem. So here, the height is 9 and the base is that segment that it is perpendicular to. It's perpendicular to those bases. So obviously I don't have the base, but I do have a right triangle. I have the height and I have the length of the hypotenuse. So I can substitute those in. B squared plus 9 squared equals 12 squared, and use the Pythagorean theorem to find the length of that base. So b squared plus 81 equals 144. So b squared is equal to 63. B is equal to the square root of 63. And I told you can go ahead and put that in decimal form, so that's approximately equal to 7.94. So now you have the length of the base and you have the height. You can go back to the formula and substitute that in. 7.94 times the height, which is 9, and that gives you an area of 71.44 inches squared. You could leave it in simplest radical form if you wanted, but you can just convert it to decimals if you prefer that. Question number 2, you are given that this is a kite and asked to find the area. So to find the area of a kite, we know the area is equal to 1/2 diagonal 1 times diagonal 2. So if I call this diagonal 1, I can see that that is equal to 26. If I call this diagonal 2, I know that I don't have any information about that at this point. But I know it's a kite, so I know that these two segments are congruent. I know that this is a right angle, and so I know that I can use the Pythagorean theorem. I'll call this segment A, and I can use the Pythagorean theorem to find the length of that segment A. So I have A squared plus 24 squared is equal to 25 squared. A squared plus 576 is equal to 625. So A squared is equal to 49. A is equal to 7. So if A is half of that diagonal is 7, then D2 is equal to 14. So then I can come back up to my formula and substitute in the information that I have. So the area is equal to 1/2 diagonal 1, which is 26, times diagonal 2, which is 14. And then I would get that the area is equal to 182 meters squared. Looking at number 3, this one tells me it is an isosceles trapezoid. So I have to think about what I know about an isosceles trapezoid. I know that the base angles are congruent. I know that those two legs are congruent. I know these two are parallel. I can construct the altitudes right here. And I know that I then have two congruent triangles here, and in the center I have a rectangle. So that allows me to take the information I have to find what I need for my formula. My formula, remember, is the area is equal to 1/2 base 1 plus base 2 times the height. I have base 1, I have base 2. Now I need the height. So I'm going to focus on this triangle. If the hypotenuse is 5, and then I look at the difference in the bases, the difference in the two bases is 6, because this is 12, that means that the difference between 12 and 18 is going to be split between these two triangles. So this will be 3 and this will be 3. You might recognize pretty quickly that that's a 3, 4, 5 triangle, so the height is equal to 5. You could use the Pythagorean theorem if you didn't recognize that and find that that was 4. So now I can just take the formula, 1/2 b1, which is 12, plus b2, which is 18, times the height, which is 4. So I get 1/2 30 times 4, or 60 yards squared. Number 4 asks me to find the area of an equilateral triangle, and the piece of information that I'm given is that the side lengths are 20. So I can draw an equilateral triangle. The side lengths are 20 inches, and they are all the same. Remember, an equilateral triangle has 3 equal sides and 3 equal angles. Therefore, each of these angles is 60 degrees. So when I construct the altitude of this triangle, it actually bisects that and divides it into 2 congruent triangles, each of those being a 30, 60, 90 triangle. So if the side length is 20, then half of it is 10. I need the height. It's a 30, 60, 90 right triangle, so I know that the height is going to be equal to 10 times the square root of 3. So the area of this triangle is equal to 1/2 the base times the height. So 1/2 the base of this triangle is 20. The height of this triangle is 10 square root of 3. So the answer for this problem would be 100 square root of 3, which is approximately equal to 173.2 inches squared. Number 5 says the area of a parallelogram is 98 inches and the length of the base is 7. Find the height of the parallelogram. So the first thing you want to do is remind yourself what a parallelogram looks like. And maybe you want to label it as well. So if you have a parallelogram, looks like that. So it tells you that the base is 7. The height is perpendicular. And the area is equal to 98 inches squared. So the formula to find the area of a parallelogram is base times height. Substitute in the information you have. The area is 98, the base is equal to 7, and you are looking for the height. That one's pretty easy to solve. You divide both sides by 7, you will get that the height is equal to 14 inches. Number 6 asks you to find the area of the regular hexagon, and the piece of information given is the length of the apothem. So again, this is testing your vocabulary, trying to make sure you understand what length is the apothem. So since this is a regular hexagon, the formula to find the area is going to be 1/2 the apothem times the perimeter. You have the apothem, that's given. But you want to go ahead and put that apothem in. Remember, the apothem is from the center perpendicular to a side. Then you want to go ahead and put in those radii right here. So now we're looking at this triangle created by two radii of the circle. Remember, this is an equilateral triangle, and the apothem of the polygon is the height of the triangle. So this height is equal to 6 square root of 3. So now, remember, the apothem divides that into two 30, 60, 90 right triangles. If this height is 6 square root of 3, the relationship between the short leg and the long leg in a 30, 60, 90 right triangle is the long leg is equal to the short leg times the square root of 3. That means that this short leg would be 6. If the short leg is 6, that's this half. We double that for 12, and we get the length of a side. So now the perimeter is equal to the number of sides, 6, times the length of each side, 12. So now I know that the perimeter is equal to 72. So I can go up to my formula and make my substitutions. The area is equal to 1/2 the apothem, 6 square root of 3, times the perimeter, which is 72. In radical form, that becomes 216 square root of 3. Decimal form, it would be approximately 374.12 units squared for the area of a regular hexagon with an apothem of 6 root 3. Number 7, find the area of the shaded region. Okay, so this is a little different. It says the figure is a regular hexagon. So again, we have that regular hexagon, and we are given the length of a side is 10. Don't be intimidated by this problem. It's actually much easier than it looks. When you look at this problem, it tells you that the length of a side is 10. If you look, we have a right angle here. Remember that this is an equilateral triangle. So therefore, each of those radii is 10. So they are both 10. So now, if we focus on the shaded region right here, I have a right triangle. One of the legs is 10. The hypotenuse is 20. And I need to find that height. Let me change that to use h, just so you're not confused by that. I need to find that height. So the area of this shaded region actually turns out to be the area of a right triangle. So 1/2 base times height. But I have to use the Pythagorean theorem to find the height. So I have 10 squared plus h squared equals 20 squared. 100 plus h squared equals 400. H squared equals 300. So h equals the square root of 300. Hopefully you recognize that that is 10 square root of 3. So now I can substitute the base and the height into my formula. So that gives me 50 square root of 3 miles squared. And you can again put that into decimal form, which would be approximately 86.6 miles squared, to find the answer to that problem. Next is number 8. It asks you to find the area formed by the following points. So let's go ahead and plot those points. The first is at -2, 2. So there's T. The next is at 4, 2. There is O. And the last is at -4, -1. And that is P. So when I look at this, I can clearly see that that is a triangle. So the formula that I'm going to use is that the area is equal to 1/2 the base times the height. The problem is I have to identify those. Clearly, this is the base. It's a horizontal line, so all I have to do is count, and I can see that that is 6 units. The height, on the other hand, is perpendicular to a vertex. So I can just make sure, the key here is that you make sure you construct that perpendicular to the base. So then I can count those units, and that is 6 units also. So I can just substitute those into the formula. The area is equal to 1/2 the base times the height, which is 36 divided by 2, so 18 units squared. Number 9 asks you to find the area of a trapezoid. So we need to recall the formula for a trapezoid. That is, the area is equal to 1/2 base 1 plus base 2 times the height. So when I look at this, I think, oh, I have base 1. I don't have base 2. And I don't have the height. So I need to find that information. I can get part of base 1, this piece right here is going to be the same as the other side because that forms a rectangle. So part of this is 9. Okay, so now look at this. I have a 30-degree angle here. That means this must be 60. Remember, they are never drawn to scale. So that means that H represents the short leg in this triangle. The relationship between the short leg and the hypotenuse of a 30-60 right triangle is the short leg is half the hypotenuse. So in this case, H is equal to 6. Now that makes this leg, so this is the short leg, that means that this is the long leg. The relationship between the long leg, which I'm going to call A in this case, the relationship between the long leg and the short leg is the long leg is the short leg times the square root of 3. So A is equal to 6 square root of 3. So this part is 6 square root of 3. So now I can add that together. 9 plus 6 square root of 3 gives me base 2. And again, you can go ahead and put that in decimal form. Don't tell me it's 15 root 3. That's not correct. Put in 9 plus 6 root 3. And you should get 19.39 as your decimal approximation. So now the area is equal to 1/2 base 1, which is 9, plus base 2, 19.39, times the height, which we said is 6. Okay, so when you multiply that all together, you should get 85.17 inches squared for the area of that particular trapezoid. Number 10 says that a trapezoid has an area of 104 units squared, and one of the bases is 10, the height is 8, and you are asked to find the length of the other base. So again, start with the formula. Area is equal to 1/2 base 1 plus base 2 times the height. Start to make those substitutions. The area is 104. One of the bases is 10. You're looking for the second base, and the height is 8. So this one gets a little tricky algebraically. I recommend the first thing you do is just go ahead and combine the 1/2 and the 8 so it looks a little nicer. So I have 104 is equal to 1/2 times 8 would be 4 times 10 plus base 2. Now, you can go one of two ways. You can either divide both sides by 4, or you can use the distributive property and distribute that 4. So let's do it that way because I think that way is a little cleaner. So I have 104 is equal to 40 plus 4b2. Then you're going to subtract the 40 from both sides. So you would get 64 is equal to 4b2. Then divide both sides by 4, and you would get that b2 is equal to 16. And that's the answer to the problem. Again, the strategy is to start with that formula, see what you have, and then find the missing pieces. Number 11 says find the area of the regular pentagon. So this is a regular pentagon. This one's fairly direct because it's a pentagon, regular pentagon. We just go straight to the formula. Area is equal to 1/2 the apothem times the perimeter. The apothem is right here. The perimeter is going to be the number of sides, 5, times the length of each side, 16. So the perimeter in this case is 80. Go back to the formula and make your substitutions. Area is equal to 1/2 the apothem 6 times the perimeter 80. So the area in this case is equal to 240 centimeters squared. Number 12, a little more difficult. Again, we're going back to that regular hexagon. We have a side length of 14 feet, and we have to find a few things. So here's the formula. Area is equal to 1/2 the apothem times the perimeter. What information do we have? We know a side is 14. We know there are 6 sides. Therefore, the perimeter is equal to 6 times 14, which is 84. So it's 84. The perimeter is 84. Now we need to find the apothem. Again, go ahead and construct that central angle, or that equilateral triangle. Remember, this is that equilateral triangle. Draw it a little bigger this time. All of the sides are the same, and all of the angles are again 60 degrees. When I construct the altitude of the triangle, which is also the apothem of the polygon, of that hexagon, I then divide that into a 30, 60, 90 right triangle. If the entire side is 4, that apothem bisects that side, so this side is 7. Again, a 30, 60, 90 right triangle. The relationship is the long leg is equal to the short leg times the square root of 3. So in this case, the apothem, A, is the long leg. A is equal to the short leg is 7 times the square root of 3. Go to your formula and make your substitutions. The area is equal to 1/2 the apothem, 7 square root of 3, times the perimeter, 84. You can leave that in simplest radical form if you would like, which would be 294 square root of 3, or give me the decimal approximation of about 509.22 feet squared. Moving on to number 13. Oh, this one looks a lot trickier than it actually is. This is the shaded region. Didn't show well on my form, but hopefully it shows well enough on your form. And again, you are told that it is a regular hexagon and you are given a side length of 6. So one of the keys to this particular picture is to recognize the two shapes that make up this shaded region. So I'm going to draw in a radii, another radii right here. So let's identify some of the lengths we have. Since this segment is perpendicular to this base, that must be the apothem, A. This is, again, a side. The side is 6. And I'm looking at this equilateral triangle. I told you in class this equilateral triangle is going to be critical on this quiz. So there's my equilateral triangle. There is my apothem. The altitude of the triangle is the apothem right there. If the side is 6, remember that is bisected, so that means that this part is 3. So here's my 30, 60, 90 triangle. There's a 3. The apothem is equal to 3 square root of 3. So now, what do I have to think about what I have actually? I have one complete equilateral triangle and then half of a triangle. So you can think of this as actually 3 congruent triangles, can't you? So you could look at it that way and just find the area of this particular triangle. The area is equal to 1/2 the base, which is 3, times the height, which is 3, square root of 3. So the area of one of those is going to be 1/2 of 9, or 4.5 square root of 3. And then to find the area of the shaded region, you're just going to multiply that by 3. So you would get approximately 48.5 root 3, or that's what you get, which is approximately equal to 83. Oops, sorry, looked at the wrong answer. Let me back up. Let me erase that. The shaded region is equal to 13.5 square root of 3, which is approximately equal to 23.38 yards. Again, that problem isn't hard. It just requires you to start labeling the dimensions that you have and to start to break those polygons into the triangles so that you can get the information. Number 14, and these are a little tougher to look at. These are regular triangles, which means that all of the sides are equal, all of the angles are equal. So when you look at this, now you've been given the length of the radius. So in order to think about this, we're going to have to draw in another radii and get that central angle measure. So the central angle is equal to 360 divided by the number of sides, which is 3, so that's 120 degrees. So now I have this triangle. When I construct the apothem is here, from the center perpendicular to a side, That bisects this and makes this 60. That's the right angle. That's 30, and this is 10. So now I'm looking at this 30, 60, 90 triangle with a hypotenuse of 10. Remember, the short leg is opposite the 30-degree angle, so this is the short leg. That's represented by A, and that's half the length of the hypotenuse, so A is equal to 10. Remember the relationship between the short leg and the long leg is opposite the 60-degree angle, is the short leg times the square root of 3. So this long leg, I'll call it B, is equal to 10 square root of 3. So let's go back to the original picture and see what information I have at this point. I have the apothem, which is 5. I'm sorry, I wrote that as 10. We need to fix that. It's late, I'm a little tired. Sorry, that's 5 because it is half of 10. So make sure you make that correction. So I have the apothem, which is 5. I have the length of this long leg for this triangle, which is 10 square root of 3. That means the entire, no, 5 square root of 3. Boy, I corrected it there and then I didn't correct it here. 5 square root of 3. Let me correct it down here as well. That is 5 square root of 3. Okay, so the apothem is 5. The length of the side is 5 root 3, but that's only half of it. To get the entire side, the length of this entire side, because this is 5 root 3 as well, so that side S is equal to 10 square root of 3. I just add those together. So now I can find the area of this triangle by using the area is equal 1/2 the apothem times the perimeter. The apothem in this case is 5, and the perimeter is 3 times 10 square root of 3. So I have 1/2 of 5 times 30 square root of 3. And that would be 75 square root of 3, which is approximately equal to 129.9 inches squared. Okay, so that's one way to look at that. That's probably the easier way. You could find the height. Let's take a look at it that way, actually. If you recall, the center of the circumscribed circle of an equilateral triangle is the incenter, it's the centroid, it's the circumcenter. They all occur at that same point. So that tells you the distance from this center to the side is 1/3 of the entire length. So if that is 1/3, then the height of this is going to be 15. So if you remembered that, you could use the formula area is equal to 1/2 base times height. In this case, 1/2 the base, which was 10 square root of 3, times the height, which is 15. And again, you would get 75 square root of 3. So kind of two ways to do that. The second requires you to remember that that is the centroid, and the centroid is 1/3 of the distance from the side of that median. Finally, the last problem, again, it's a triangle, and you are given the altitude, or you are asked to find the altitude or the height of this regular triangle. And then you're asked to find the area. So this is a little different because now you are asked to find this height of the triangle. So that's what we're looking for. We're looking for that height. Again, we have this central angle, which is 360 divided by 3, which means the central angles are all 120 degrees. The apothem, right here, the apothem, let me put that in red. This apothem bisects that 120 degree angle, which means this is a 60 and this is a 30-degree angle. That means I have the hypotenuse, that's what's opposite the right angle. So the apothem right here is also the short leg, so the apothem is equal to 4. The relationship between the short leg and the long leg, this long leg, is that the long leg is equal to the short leg times the square root of 3. So now let's kind of take a look at this. This is one of those where you have to kind of redraw the picture and look at what you have. Because you are asked to find the height of the triangle, now I'm taking this, what I have right here, and I'm going to redraw that, and I'm going to leave out that radius. So now I know that this side is 4 square root of 3. This is a regular triangle, so that means this angle is 60 degrees, and this angle is 90 degrees. And now my 30-degree angle has moved up here to the top. And I need to find the height of this triangle. So the relationship between the long leg and the short leg is the short leg times the square root of 3 gives you the length of the long leg. Well, in this case, long leg is h. The short leg is 4 square root of 3 times the square root of 3, which gives me 4 times the square root of 9. Square root of 9 is 3. So that gives me a height of 12. So now you're asked to find the area of the triangle, and since you have that, you can choose either formula. I'm going to use the area is equal to 1/2 the base times the height. So in this case, 1/2. Now the base is going to be 8 square root of 3, and the height is going to be 12. So this should come to 48 square root of 3, which is approximately equal to 83.14 inches squared. Okay, and that ends the review sheet for the quiz.